Okay, so this is where we just left off with mid segments of a triangle. And this should once again sound familiar to us because we have talked about mid segments of trapezoids before, okay, back in chapter 6. And so the concept of a mid segment of a triangle is the exact same thing. The only thing is we only have one base. And so a mid segment of a triangle is a segment with endpoints that are midpoints of the two sides of the triangle. So if I would just quickly sketch my triangle, all right, and I'm going to eyeball the midpoint of this side, and I'm going to eyeball the midpoint of this side, and then I connect them. This segment right here of AB is my mid segment, okay? And so that was just a definition, and now we have a theorem, all right? And this theorem is very similar to what we talked about with trapezoids, all right? And it says that the mid-segment of a triangle is parallel to the one side, and its length is 1/2 the length of that side. And this should make sense to us because when we were talking about mid-segments of a trapezoid, all right, and let's say that this is our mid-segment, we found that the length of this mid-segment right here was 1/2 the sum of the two bases. Okay, that's for trapezoids. But for triangles, we only have the one base. So this length of AB has to be equal to 1/2 that base or that third side that's not being bisected. And so example 4 says DE is the midsegment of that triangle ABC. And so what can we conclude? And so we're given in letter A that AB is 7, and we need to find DE. And we know that DE has to be half of this base of 7. And so that means the length of DE is 3.5. All right. For B, we're going backwards. We're now given that DE is 14, and we need to find the length of AB. And once again, we know that this has to be half of AB, and so we have to double it in order to get AB, which would make that 28. Okay? And now we're going to throw in some algebra, all right? And once again, we know that DE, the length of DE, equals 1/2 of the length of AB. And so if I fill in, all right, the fact that DE is 4x plus 1, and the length of AB was 18, I can nice and easily solve this, and I get 4x plus 1 is equal to 9. Subtract that 1 over, I get 4x is equal to 8, which means that x is equal to 2. Okay? Now, example 5 is once again applying this. And so in this figure, we're given x, y, and x, z are mid-segments of this triangle. So we now have two mid-segments of x, y, and xz, right? And so the first question is asking us to find xz. And so the big idea here is you just have to make sure you know, all right, what is the base that we're looking at for that xz? And so that means that RT is the base of that. And so these two lengths are connected, all right? XZ has to be half of RT. And so we know that RT is 13, so the length of XZ has to be 6.5. Okay? Now, for the next one, we have to find ST, all right? And this is going to be based off of the mid-segment of XY. And we know that that mid-segment of XY has to be half of ST, so we have to double it to get the full length of ST, which means that ST has to be 14. Okay? All right, now our last one is talking about the angle of RYX. So this is what we're looking for right here, that angle, okay? And so this is based off of the fact that we have these two mid-segments right here, okay? And this mid-segment is parallel to this base. And so when we think about parallel, all right, we should think of our special angle types because this segment right here is a transversal to those two parallel lines. And so if you look at this angle 124, that is an alternate interior angle to that angle RYX. So the measure of RYX has to be 124. Okay? All right, now our next set is this corollary 6.1, all right? And it says that if there are 3 or more parallel lines that intersect 2 transversals. So let's pause there. If you look at this example 6, we have 3 parallel lines, all right? And our 2 transversals are this line AC and this line of EG, all right? So this picture right here is a direct representation of this corollary 6.1. But what that corollary 6.1 is saying is that it cuts the transversals into proportional segments, right? So if I look at my 2 transversals of AC and EG, we look at the segments that are now split. And these segments right here are cut proportionally. So what that means is I can write my scale factors or my proportions and say that this segment of AB, all right, and I'm going to stay within that same segment, all right, or within that same transversal, is to BC. And when I match that up, all right, I have to look at the same segments that correspond with it. And so because EF is formed by the 2 same parallel lines as AB, all right, EF has to correspond with AB, and FG has to correspond with BC. Now, once again, we can flip-flop those. All right, we can do the interchange means. And let's say, well, I want to set AB is to EF because they're made by the same 2 parallel lines. Then I have to match up the same segment, all right, within that same line. So I have to match up BC with AB. And then FG corresponds with BC. So either of these are the same. All right, once again, it's the interchange of means, all right, property, okay? So example 7 then says to find x. All right, before we start, I have to tell you first that these lines are parallel. If we didn't have that we couldn't do anything, okay? And so what I'm going to set up here then is I know that these segments of 3x and 2x and 18 and 4x are proportional. And so I'm going to do 3x is to 18 as 2x is to 4x. Now, before I begin, I like to simplify first, especially on this one, because I would have to factor or do some more algebra than I really want to. And so I'm going to look at this first scale factor, and I'm going to say, well, my 3 and my 18 can simplify. So that simplifies into x over 6 equals, and then this one is the most important because my 2 and my 4 simplify into 1/2, all right? But my x's also cancel out. So I'm just left with 1/2 on that one, okay? And so now we nice and easy cross multiply. We get 2x is equal to 6, which means x is equal to 3. Okay? All right, and I'm going to stop there one more time, one more video. All right, it'll be a quick one.